Alright, looks like we are live and ready to go. Welcome to Home of the Neon Alliance, the first and only call-in show dedicated to the simulation hypothesis. I am the one and only RAO. Usually I like to do a little bit of research before I get started on a show. This time, I'm just going to tell you what I've learned, what I've figured out from this. We're going to be talking about the double-slit experiment and its history, along with its implications regarding the simulation hypothesis. Well, it starts out with photons being launched into these double slits. Now, when you pour particles like sand into it, it's going to make two piles. When you put it in water and you drop beads behind it, it's going to make these waves and make an interference pattern where you'll have a line of high intensity, a line of two lines of low intensity, and then these stripes for the interference pattern. Now, when you take photons and you fire them at the double slit, what we see is an interference pattern that would imply that photons are waves. So the next experiment they did was, well, let's see what slit it's going through. Because these this experiment was with electrons. I apologize. This was the electrons experiment was the first one. And they were just asking, well, which slit is this electron going through? Because an electron is a particle, but for some reason it's moving like a wave. So when they check which particle which slit it's going through, the wave pattern disappears and we get the particle pattern. So why is it disappearing whenever we figure out what side it went through? Why is the waveform collapsing? And that brought us to the delayed choice, where the particle went through the double slit. Then it got detected after it went through, and the waveform still collapsed. So they're wondering if their measuring devices themselves are what's causing the waveform to collapse. The last experiment that I'm going to talk about is going to be the quantum eraser double slit experiment, in which the photon is split in half. It's split into an entangled pair, and one side goes directly through and hits the backboard after it goes to the slits. It goes through the slit, then it gets split off. So it hits this backboard first. Then on the other side, it's got a system where half the time it's going to go through this mirror, and the other half of the time it's going to hit the mirror and reflect off. If it hits one way, it hits detector 1, but you don't know it hit detector 1. If it goes to the other slit and it hits detector 2, you won't know if it hit detector 2. Now, if it goes into detector 3, you'll know it went into the first slit. And if it goes to detector 4, you'll know it went through the second slit. So it's being measured every time. So the only variable that we have now is observation, is the measurement being observed. And what we found out with this test is that if it goes through if it hits detectors 1 or 2, what we see is the interference pattern. If it goes through detector 3 or 4, we see a particle pattern, letting us know that these photons that hit the backboard that get the interference pattern or the particle pattern I am using the term know loosely, not to say that the particles themselves have conscious thought, but it's like the particle knows what slit or what detector its entangled pair is going to hit, even without it ever touching the detectors, touching the mirrors. It doesn't even touch the mirrors yet. It's a half silvered mirror, something like that. But it never even touches those. And this particle already knows where its entangled pair is going to end up. And observation is the only variable. It leads me to think about it in a similar manner as the frame perfect glitches that we see in speedruns. For instance, in Ninja Gaiden, I'm going to use this as an example because it's one of the ones that I do run. But the example of Ninja Gaiden is where if you get hit, you'll have knockback and you'll have invulnerability frames, meaning a short little brief period where you're basically not being affected by other matter. So when you do something like that, you can actually boost up and get into places where you wouldn't normally be able to get to. But it's using those small glitches to your advantage. Now, I'm not saying that there's any testable way that we can use this to our advantage, but it does look like a repeatable glitch where observation determines if the particle is going to be a wave or if it's going to behave like a wave or a particle. And it feels like one of the biggest questions that we have in quantum physics. It also leads me toward the idea that our universe is simulated because of the fact that we have this frame perfect glitch where something moving at or close to the speed of light changes to a point that we can't even tell if it's matter or not. Which is exactly what we would expect to see in a better running system, is you'd have to get close to the speed limits of that universe in order to start getting it to break down. When you get into the smallest and the fastest is where you're going to find the glitches. And when we got to the fastest, we observed glitches. And let's see, we have the phone lines open up if you want to give us a call right here, 307-363-1230. And we'll be waiting for your calls. I usually just like to have this introduction where I'm bringing up a point of evidence, a philosopher's idea, something to where I've basically got a topic of the show so that a skeptic can call in and argue my evidence or my philosophy, or somebody who has a different claim can come in with their claim. We don't have to stay focused on the topic for you to call in. We can call in and talk about what you want to talk about. But just me having a topic to bring up every week and talk to you all about, it gives the skeptic audience something that they can interact with. So yeah, I like doing this. I like researching it. I like talking about it. It's fun. It's fun to explore and figure out what reality is all about. Figure out what we got going on here. Because these are the questions that make us think. The questions about our reality. And when we actually challenge ourselves with these questions that dig into what reality is, that, to me, is enough reason. I mean, let's say that I'm wrong about the simulation hypothesis. Let's say that I spent my life exploring, trying to figure it out, but I ended up being wrong. Everything that I did to be wrong is something that's going to help the next person so that they can have a better idea of what is and isn't. Because if I'm wrong about the simulation hypothesis, then it isn't. But you can see how I think about it, why I think it is the way I think it is, and figure out what mistakes I made along the way just from having that available to you. So, right or wrong, just trying to figure out what the most real thing is. Trying to figure out what the most true explanation is. I mean, that should be worth it in itself to me. Check out the call line again. We still have open lines. We have not, actually, we've yet to receive a call into the show yet. So, I'm still waiting on that first caller. I've been promoting it on the Simulation Theory group on Facebook. And I'll promote it among my skeptic friends as well. And that's basically the only promotion I've got right now. I mean, I know it's starting off small. I know that it's going to have to build. And getting those calls is going to make the show. Interacting with you, letting me know what you think, and letting me know if you think I'm right, if you think I'm wrong, and your evidence on the subject, your thoughts on the subject. Because I'm not here to tell you I'm right. I'm here to tell you that I think this is what's going on. I mean, if I start giving you answers, I'm basically trying to indoctrinate you, and I don't like that. What I want to do is I want to encourage you to ask questions, to question the answers. I mean, we started doing that as kids. When we were kids, it was always, why is this? Why is this? Why is this happening? Well, how does this explain this? You just told me this. Well, like, why is the sky blue? It reflects off the water. Why is the water blue? It reflects off the sky. Hold on. Something's not right here. And those questions, in some people, they eventually die off. And you just get it replaced with, what's the answer? Not, what questions will the answer lead to? Because that's what I'm interested in. That's what I want to see, is what do these questions, or what do these answers leave for you to question again? How far down this rabbit hole can we go? That's what I want to do here, is I want not just to figure out the answers, but I want to find out how many questions we can ask once we get to that next step. Once we figure out more about our reality, what other questions are going to be there for us to ask? Check one more time. All right. I believe that's gonna make the show for now. We're going to have an episode next week. I'd like to get into more of the ancient ideas. We're going to be talking about Shang-Chi, and I think that's how to pronounce his name. I'm going to look more into it over the course of the week. Uh, and Plato, and we might even get into Rene Descartes next week. So that's kind of what I've got set up for. That's kind of what I got set up for going on next week. Um, During the week, you can find me on Twitch at www.twitch.tv/the one and only RAO, all one word. You can find my YouTube that'll have my game highlights at the one and only RAO. And once I start getting calls in, you can check back. You can check back with Home of the Neon Alliance, where I'll have the calls specifically edited between each other, so you could just play back one call instead of having to rewind through the episode and look for it. So make sure to keep that in mind. Like I said, I didn't get any calls this week, so next week we're gonna be trying to get we're gonna get a call in, hopefully, and from there I'll put that video in sometime midweek so you can watch the introduction and then the call, or you can just skip straight to the call on another video. But I think that's all I've got for you next week. Until next time, keep it real.